Welcome and thank you for joining today's webinar. Boundary Devices and NXP are pleased to present how to enable your multimedia application using the Nitrogen8M Mini single board computer. My name is Peter Hauk, Director of Sales at Boundary Devices, and I will be your host. Before we begin, some housekeeping. All listeners will be placed in listen-only mode. On the right-hand side of the webinar tool, you will notice a questions toolbar. You can submit your questions throughout the webinar presentation. We will also have a dedicated question and answer session at the end of the webinar. For information about future webinars or to receive our newsletter, please register at boundarydevices.com and click Sign Up in the top right-hand corner. Below our agenda for today, in just 1 hour, we will provide an overview of the Nitrogen8M Mini single board computer, including operating system selection and a detailed review of the different multimedia capabilities. Joining us today from Boundary Devices are CEO Pejman Kalkoran and Senior Software Engineer Gary Bisson. Our special guest this month, NXP's Robert Thompson, who is the Director of Global I.MX Ecosystem. And now, on with the show.
Thank you, Peter. My name is Pejman, and I am CEO of Boundary Devices. And first, I wanted to take a moment and thank everyone for joining us today on this webinar discussing the I.MX 8M Mini processor. We've been very happy with the I.MX 8M Mini and are really excited to share some of the things we've done with it. So Boundary Devices was founded in 2003, and for the last 17 years, we've been designing ARM-based embedded computer platforms for the general embedded market. And we were founded with a singular focus of introducing ARM technology in a world dominated by x86 machines. Our founders, who are still with us today, leading our engineering teams, were driven by a passion for low power, low cost computing systems. 17 years later, ARM technology is everywhere. So our focus has shifted slightly to helping companies dig through the clutter and find the right technology solutions for their business. Our first customers were large stadiums looking to provide electronic unmanned access control solutions. As you can imagine, these stadiums had limited technology experience and really relied heavily on our significant hardware and software expertise. We were able to develop our suite scanners with ARM technology and are currently on our 5th generation access control system, which will be installed in the brand new SoFi Stadium in Los Angeles, featuring I.MX technology. Getting into SoFi Stadium, which is a $5 billion technical marvel, was no easy feat, but it demonstrates our leadership in technology as well as our reputation of being a customer-first company. From our headquarters in Lake Forest, California, our expert team of hardware and software engineers are ready to help new customers design and develop their next generation of technology products. So what sets us apart from our competition? We have serviced thousands of happy customers over the years and really gained valuable expertise, especially as it relates to I.MX design. These days, there's a significant amount of information on the internet, from both a hardware and software perspective. The reason customers choose to work with us is to first, accelerate their time to market, and second, to utilize our significant expertise to design and manufacture a better product. We've manufactured a ton of I.MX boards and really know the manufacturing pitfalls that potentially your contract manufacturer doesn't. We have our own in-house hardware and software teams, so we don't outsource the core parts of our design. But we do have quite a few software partners that can help with application development or more complex operating system development. We have a lot of experience with the I.MX family, starting with the I.MX 31, and you can see the full laundry list of processors that we've worked with over the years, including the I.MX 8M Mini. We were selected by NXP as the launch partner on the I.MX 8M mini processor and have already completed numerous successful designs and are in full production with the part. So we're a total solution partner, and many of our competitors are design houses or system on module vendors, whereas really we can do all of it. We can do the hardware, provide the software BSP, as well as manufacturing and integration. We really believe in having unmatched service and support. We are very passionate about the embedded community, and we can contribute significantly to open source projects. And through our website, you can see a wide variety of how-to guides and software options to help customers get the answers they need. We manufacture in the US, which is a point of pride for us. With everything going on in the world, with tariffs from Asia, the global pandemic, supply chain is becoming a bigger factor in decision-making process for customers. And the fact that we are US based is a big value, especially for our North America customers. Even though we do manufacture in the US, our pricing is still competitive with the global pricing market. This is because our supply chain is optimized for I.MX, and we don't build any other types of processor platforms. And as you can imagine, a lot of these designs, they share the same core components. So our high volume manufacturing allows us to have very competitive pricing. We provide complete custom solutions at very reasonable NRE costs because we've optimized our processes and our designs, which are already based on existing proven reference designs. There's a lot of efficiencies which allow us to have affordable rates. We are an NXP Gold partner and have completed hundreds and hundreds of successful designs and are very proud of our partnership with NXP. We have a flexible business model because there's really no one-size-fits-all approach with us. Whether it's a single board computer, a system on module, or a custom design, or any modification to these three, we are open to do whatever it takes to fit the customer's requirements. And finally, we provide a minimum 10-year availability on all of our products. This is an overview of our Nitrogen platform, which is our primary hardware platform. Within the Nitrogen platform, we have system on modules, we have single board computers, and we have custom designs. We're also releasing our I.MX 8M Plus system on module in the next couple of months, which will be our smallest SOM to date, and we're very excited about the addition to our family. Really, the purpose of this slide is to touch on the fact, to really show that we've really done it all. We've been in every industry. We understand what it takes to get products to market. And a lot of times, when it's the first time customers are trying to bring an embedded product to market, they make selections or even mistakes that will be really difficult to change down the road. And I think that's one of the advantages that we have because of our experience in these different types of industries. We know what it takes to get a medical device product to market. We know the supply chain and logistical challenges getting an aviation or aerospace product to market. And we understand the harsh environmental concerns of outdoor products, such as outdoor digital signage or kiosks. And this allows us to design in the proper specifications to address problems now that you may run into in the future. So I will now hand it over to Robert to discuss a little bit more about the I.MX 8M Mini family.
Great. Thank you, Pageman. Welcome, everybody. I'm going to take a few minutes to give you the background on the 8M family. Thanks for switching over, Peter. So really, I just want to start off by giving a little bit of context, although Pageman did a great introduction. If you look at the initial I.MX 6 portfolio of products that launched to the market all the way back in 2011, they really introduced the idea of a portfolio that scaled from a single core to a quad core, but utilizing the same set of IP blocks. And so we're able to maintain both pin-to-pin and software compatibility. This introduced the ability for designers to scale up and down performance during development without having to reboot the design process from scratch. As the demand for application processors has grown, new variants of the I.MX 6 portfolio were added. However, overall software compatibility, the same Linux and Android BSPs that Boundary devices take from us and modify for their customers' needs, still run across the entire portfolio, so enabling our joint customers to develop a portfolio of products. The I.MX6, with the help of companies like Boundary Devices, has been successfully designed into devices as varied as high-end auto infotainment systems to single-function temperature tracking instruments. With this success, we saw the opportunity to bring greater performance and features and improve power with the I.MX8M portfolio. The 8M portfolio is split into three main families. The I.MX8 featuring the 8 Quad Max that takes the next step in graphics performance, which is with a 6 times improvement from the I.MX6 Quad Plus, enabling up to 4 high-definition displays. The 8X, aimed at the industrial market with the right balance of power, performance, and safety features. And then the 8M family that is really optimized for video, high-definition audio, and voice, now key features across many industrial and IoT markets. These three families are aimed to cover the rapidly expanding use cases and vertical markets that Pageman alluded to in the previous slides. These ARM-based application processes are now addressing this wide variety of usage models and markets. With the rapid expansion and need for vertical specific IP, pin-to-pin compatibility is maintained within the families, and software reutilization with the same BSPs extend across all three families. So let's look at the 8M family in more detail. The 8M portfolio consists of three families that are launched, and one, the 8M Plus, that Pageman mentioned earlier, that will launch near the end of this calendar year 2020. The 8M Quad launched back in 2017, and it was the first I.MX part that specifically aimed at the multimedia market, supporting such features as 4K HDR, high-definition audio, while maintaining the family approach of scalability with the Quad, the Dual, and the Quad Lite that we started with the I.MX6. The 8M Mini and Nano launched in 2018 and 19 and transitioned to the process node of 14 nanometer FinFET, so significantly reducing the power profiles while adding key features such as video encode and support for digital microphones. The 8M Plus maintains the same 14 nanometer FinFET process node, but takes the next step in application process development by adding a dedicated neural network accelerator, an ISP, to enable a range of machine learning usage models with low latency and power. The 14 nanometer FinFET choice for the Mini and the Nano enable pin-to-pin compatibility, but also faster operational speeds for the core complex of A53s at lower power consumption. This power efficiency and performance is only one of the key features that we present with the Mini. The power and scalable performance of the Mini makes it perfectly suited for a range of media-rich usage models covering video, graphics, and voice, with support for H.264, H.65, VP8, and VP9 video standards, along with a dedicated 1080p 60 frames per second video encode engine that can support H.264 and VP9 video standards. The two dedicated graphics processing units, one 3D and one 2D, provide for a rich display experience with Android, for example, and up to 1080p 60 via the MIPI DSI interface. Enabling these features in a 14 by 14 millimeter package size that allows you to route into a 6 to 8 layer board and a range of memory choices covering DDR3L, DDR4, low power DDR4, enable the Mini to be applicable to a wide range of different verticals, both consumer and industrial. The industrial qualification and NXP longevity program enables designers to utilize these parts for all of these key markets. Since its launch, the I.MX Mini has been rapidly taken to production in an array of markets, for consumer to IoT, smart home, for example, and industrial markets from automation to healthcare. However, to enable the vast majority of our customers to get to market, we form key partnerships with companies such as Boundary Devices. As Pageman mentioned, they have a wealth of experience with I.MX. They understand our roadmap, where we're going, and jointly we go after and focus on the same markets and verticals. Boundary takes our chips and they create both single board computers and system on modules that fully utilize the features, and they produce it in many form factors that enable you, the end customer and the designer, to shorten your time to market, so increase your product success and make sure that we are all jointly successful in moving forward in the market. And with that, I'll hand it back to Pageman, who can take you through some of the details of the Boundaries 8M Mini Nitrogen platform.
Thanks, Robert. So I'm going to jump into a little bit of the hardware platform. I'm not going to go into a whole lot of details about the boards. All the details are available on our website. But essentially, we have two platforms that we call the single board computer and the system on module. So the single board computer, which you see on this slide, it really has two specific purposes. The first purpose is to provide customers a development platform that they can do their evaluation, board bring up, processor validation, application development. So we really wanted to put as many features as we could on the board and provide the ability for customers to do some development work. The board has, USB, Ethernet, Wi-Fi, audio, those types of things. The second use case for the board, though, is we have many customers that don't have the volume to either justify a custom design or even designing a carrier board. And so we wanted to make the form factor in such a way that people could really just take this board, attach a display to it, put a box around it, and ship it as a production solution as well. There's a ton of details on our website, including schematics, user manual step files, as well as all of the operating systems that you see on this page. And I'd encourage everyone to go to the website to get more information. So this is our mini SOM, our system on module, which is based on a SODIMM form factor. The couple of things I wanted to mention about our SOM is we do provide carrier board design files to customers to, again, kickstart their design process. Our tools are Altium, so we can provide our Altium files to customers. We also do no-cost reviews of customers' designs. So a customer will complete their schematic, we will review it and provide some feedback there, and again, on the layout as well. The goal is to make sure that we're getting customers to market quickly and helping them avoid any issues that may come up in the future. Again, same from our SOM module, the schematics and step files and things are all available on our website. We are working on a tablet reference design based on the I.MX 8M Mini. The I.MX 8M Mini lends itself really well because of its cost as well as its low power consumption. So for customers that are interested in a tablet reference design, please contact us and we can provide more details. So in the previous slide of the single board computer slide, I mentioned one of the reasons for our SBCs is to give customers the ability to do a full proof of concept. And to do a full proof of concept, there are other peripherals that are needed. Displays, different types of accessories, and over the next few slides, I'm going to talk a little bit about that. But really, Gary, later on in this presentation, he's going to dive deeply into all the different daughter boards that are available for the Mini, so customers can see the different use cases and different ways to do a full proof of concept in advance of a custom design. So from a display perspective, we've enabled 3 different types of displays. So 2 of these displays are 7-inch and 10-inch, or actually LVDS displays. So the I.MX 8M Mini only supports MIPI DSI output. So unfortunately, in the industrial market, a lot of these displays are LVDS. So Gary will dive a little bit deeper into this, but we have a MIPI to LVDS conversion that goes on there to drive that. We also have a native MIPI 8-inch display. And again, the purpose of these displays is to give customers something out of the box that works immediately with the board. They can start their development, they can start their evaluation. We also have a display integration package where customers can select their own display, whatever display they want to use, and they would send that to us and we would integrate it. So we would do the timings, the U-boot changes, the kernel changes, as well as integrate the touch drivers into the customer's OS of choice. We have a wide variety of accessories, so I think a couple that I'll highlight. Again, Gary is going to go into more detail on this, but we've partnered with Quectel using their cellular modem. So the one we have is the EC25A. We already have the software developed for this and kind of instructions on how to integrate this with an I.MX 8M Mini to do some cellular testing. There's different Wi-Fi modules, HDMI input modules, HDMI out. So Gary's going to go into a little bit more details on this. And if you go to the mini pages on our website and click accessories, you can see the full list of accessories that are compatible with those boards. So with that, I'm going to pass it over to Gary to jump into the technical discussions of all of these accessories.
Gary, you have control.
All right, thank you, Pejman. So yes, at first, let's talk about the software side of things. And first, why is software such an important piece of any new project? As Pejman mentioned, boundary devices have been doing this for some time now. And from our experience, software issues can really be a major roadblock to customers. As you know, processors are getting smarter now. The I.MX Mini, for instance, provide many features from video decoding, encoding, capture, output, and many I/O capabilities, such as PCIe, USB, Ethernet, SDIO, and so on. That means that the software stack is getting bigger and more complex. And also, what used to be a simple project with microcontroller with an LED running bare metal software is now a full-blown computer solution with a display, a touchscreen, and an operating system. And that is why boundary devices provide industry-leading software support, because what we've seen in the past is that many customers are new to this Linux Android world, but all the customers want to be able to focus on their own application without wasting any time on the BSP. And that is really what we want to support and what we want to enable every customer to be able to do. And our goal is really to get you to market quickly. That is why we provide a unique plug-and-play experience across all our software offering, which we will see during the demos afterwards. And it is also worth noting that all our OS development is done in-house for both Linux and Android. What it means to you is that our team is here to support you and to help you with no latency involved. Also, the team is leveraging all that knowledge from past experience and is sharing it with customers either through direct channels or via our website with all the technical articles that we provide on our blog or wiki. Talking about the wiki, let's have a look at what it looks like for the Nitrogen8M Mini. First, one important aspect is for the newcomers is the getting started section. What you will find there is tutorials to learn how to boot the device, how to connect it, and how to flash the OS of your choice on it. Really, once again, here the goal is to enable every customers and to give the best out-of-the-box experience as possible. Also know that we keep on adding tutorials as questions come, so feel free to reach out if anything is unclear. Then for the OS offering itself, we're going to split it in two, Linux versus Android. For Linux, we have different options because we do not want to force customers to use one specific solution. And there are two main approaches when it comes to Linux on embedded system. The first one is to use a build system, which, as the name suggests, will build every package from scratch, and those packages will be included in your final image. In that category, we have the most famous and most complete option, which is Yocto. That is what is provided by NXP, and it is widely used in the industry. As you can see, we are up to date with the Zeus release, and we are working on the Dunfell one that will be available in the coming weeks. We are also providing some boot to Qt images with their own toolchains to enable, once again, customers to be able to develop their Qt application right away. Then we've had some feedback from customers and especially newcomers where Yocto can seem like a complex solution. So we wanted to offer another alternative, which is Buildroot. Buildroot is, like, let's say, a simpler approach to what Yocto is. It doesn't provide as much flexibility, but still includes all the packages you need to leverage Nitrogen8M Mini features. Fun fact about Buildroot, SpaceX just announced that they were using Buildroot in their Crew Dragon display in their rockets. Also note that Boundary Devices is actually maintaining all the I.MX package in Buildroot upstream. So that is it for the build system solutions. Now the other approach is the package-based distribution. That is what Ubuntu and Debian OSs are for. The big advantage here is that if you need a tool that isn't in the original image that is provided on the website, there is no need for you to compile anything. You just need to run a command line, apt install, and the name of the tool that you need, and it will do the trick. It really is like a Linux operating system that you would get on your PC, on your laptop. And just like the other options, our Ubuntu and Debian images include all the acceleration, GPU, VPU, GStreamer plugin, and so on of the Nitrogen8M Mini, which is really a unique offering for this processor. Then there is the Android OS. No need to present it anymore. This is the most famous mobile OS nowadays. And just like Linux, you can see that we are already provide the latest Android 10 release for the Nitrogen8M Mini, and it includes all the acceleration and peripheral support. The big advantage of Android is its known API. There are many Android developers available on the market, and so it's very easy to get started and run and debug your own application right away. Also, that application will easily be portable to the next generation product. But know that choosing which operating system is the best for your project really depends on your project. There are trade-offs for each option. For instance, Android is going to be resources hungry, so it's going to require more DDR than the Linux counterpart. So really, if you're not sure of what is the best option for you, please make sure to contact us and we can discuss it and help you make the right choice. And finally, there is one more BSP available on the wiki, which is the FreeRTOS BSP. It is for the Cortex-M4 core available on the I.MX8M Mini, which is here for real-time purposes. So basically, if you have some real-time needs like toggling IOs and stuff like that, we truly recommend using the Cortex-M4, and there is a BSP for that. Now let's have a look at another aspect, which is the artificial intelligence and machine learning. We are seeing more and more requests in that field because customers want to do as much processing at the edge as possible. So on the platform, they don't want to rely on any cloud processing. That is why NXP provides the EIQ framework that includes TensorFlow Lite and OpenCV frameworks or ARM-NM. Those frameworks allow you to do things like facial recognition, object detection, image classification, and so on. As you can see in the diagram, the I.MX8M Mini is perfectly capable of doing such computation. Although, if your focus is solely on AI/ML, we suggest to stay tuned about the upcoming I.MX8M Plus solution. So Boundary Devices includes supports for those frameworks in their BSPs, and we are happy to assist you if needed. And you can see here an example of object detection. You can also note that there are several training models that are available, such as Inception or MobileNet. So now let's talk about security a little bit. Although it is a wide subject, we wanted to cover some basics as we receive more and more requests about it. It is more important than ever because vulnerabilities keep on getting discovered every day. and many are making the news considering their impact. So sometimes customers ask us, can my system be 100% secure? Well, I'm not sure we can say that of any system. However, there are some good practices that you can put in place to make your system as secure as possible. And that is what Boundary Devices is doing. And we will detail some of it here. First of all, well, you need to be able to update your device in the field, because if a bug is discovered, you need to be able to apply a fix for it. And so that includes being able to update the device in the field. So we will not cover the OTA options here, but once again, if you need any advice on that, we have several options that we can offer. And that is why, so those updates, that is why Boundary Devices is always following the latest NXP releases, because not only it provides the latest and greatest NXP packages, it also provides all the latest bug fixes for all the programs across your image. And the same goes for the Linux kernel. We integrate all the Linux kernel stable release starting with the 4.19 kernel to make sure that all the known CVEs are fixed ASAP. So as soon as a stable release is published publicly, we integrate it into our Linux kernel. On top of that, the I.MX LM Mini provides some hardware IPs to ensure security on your system. The most famous one is the high insurance boot, which we have been familiar with for years now. It allows you to authenticate the software running on your platform. It is part of the boot ROM, so it ensures the chain of trust of the bootloader loaded at first, and then you need to make sure that all the subsequent software pieces are also making sure that every piece of software is properly signed and authenticated. But there are other features that exist, such as the ARM Trust Zone, which allows you to run some application inside a trusted environment. So that will be isolated from the main OS with secure access to peripheral and memory. Also, there is the fuses that can be used to store some secrets. One nice feature about it that we've used in the past is the tamper detection that can erase those keys in case any tampering is detected. So once again, Boundary is here to help you enable those features to ensure your product security. And a final thought on software and its availability. As you can see, we rely a lot on open source software. That is why we share all of our source code openly on GitHub. So we're not hiding anything. The code can easily be audited by all our customers. And as a result, we're also proud to give back to the community when we can, which is why you can see many of the software team contributing to the upstream projects such as the Linux kernel, Yocto, Beetroot, and so on. So now let's have a look at the different demonstration. And sorry for the false advertising. We're gonna be playing some pre-recorded videos due to the different setups required. This will allow us to show more options in the limited time. So the first daughterboard that we're gonna see is the CSI daughterboard. So as the name suggests, it allows you to connect a MIPI CSI camera to it. The video will show you how the OmniVision OV5640 5 megapixel camera is working on our Nitrogen8M Mini. But it is also worth noting that this daughterboard is also bringing some other options like the I/O expansions. There are a lot of exposed pins that you can use as you see fit, such as like UART, I2C, SPI, and GPIOs. Another addition is the SPI to CAN bus adapter. We've received many requests for CAN bus support, and this approach has been proven to be very reliable in several projects already. So now let's have a look at the setup. Very simple here. You can see that we simply plug the daughterboard onto the Nitrogen8M Mini and to the OmniVision camera directly. So here is the video. It is going to show you the Nitrogen8M Mini with that OmniVision camera running Yocto Zeus with the 414 kernel. So here the user space application is a simple GStreamer pipeline that shows the stream received from the camera. Here the stream is a 720p but at 30 FPS. So let's have a look at another option that we offer, which is the HDMI input daughterboard. Same as for the CAN bus, we've received many requests about HDMI input, which isn't supported natively. So fortunately, there are some bridges that exist that can transform the HDMI input signal into MIPI CSI. This allows us to capture HDMI input up to 1080p. And regarding the software, once again, it is supported out of the box on all our BSPs, as it will show up as a standard camera to the OS. Here is a picture of the setup. Once again, very simple. We've just replaced the OmniVision camera with that HDMI input daughterboard, and we will connect actually a previous generation device, which is a Nitrogen8M into that HDMI input daughterboard. So here, once again, the Nitrogen8M Mini is going to be running Yocto with the 414 kernel, whereas the Nitrogen6 will be running Debian. On the Nitrogen8M Mini platform, once again, it is using a standard GStreamer pipeline that will just stream what we receive on the MIPI CSI. And here we can see the output of the Nitrogen6 being streamed on the Nitrogen8M Mini. Next daughterboard is about the other way around. If you want to connect an HDMI display to the Nitrogen8M Mini, as we've seen, the I.MX LM Mini processor has a MIPI DSI output. And so once again, we're gonna use a bridge that's going to be converting the MIPI DSI signals into HDMI1. And once again, it supports up to 1080p at 60 FPS. One of the neat thing you're gonna see is that, as I said, like we want to provide a plug and play experience. So as soon as you plug that daughterboard to the Nitrogen8M Mini, the bootloader will automatically discover the daughterboard and set up everything, all the display accordingly. So there is no setup required. As soon as you plug it, it's gonna know that you want to connect an HDMI display to it. So here the setup, once again, is very simple. Simply connect that daughterboard to the Nitrogen8M Mini and then to the HDMI display. So pretty much the same setup as before. Yocto Zeus release, 414 kernel with the DSI to HDMI daughterboard. So here the OS was already booted up, and the 3D, we can see the 3D application running. Now, the next daughterboard is still about display output, but from a different technologies. For those who have been using the i.MX 6 processor in the past, you most likely had to use LVDS display. This has been our case for many years, and over time we found displays that were perfect for our customers, both for their quality and price. So using the same LVDS display for Nitrogen8M Mini really was of interest to us. So that's why we decided to take a look at it, and that's why we're providing this solution, which is using the SN65 DSI port. And that allows us to reuse that exact same LVDS display for the Nitrogen8M Mini, as the part will convert MIPI DSI to LVDS. It's actually simple link, single link LVDS. Here is the picture of the setup. Once again, very easy. You simply connect the display to the Nitrogen8M Mini, and just like before, the bootloader will detect it and will set up the display accordingly, and you have nothing to do. It will recognize the display and set it up properly for the OS. So here, it's still gonna be using the Yocto OS, but with the boot to Qt flavor. So it's gonna be running the Qt launcher that you can discover as well on our website. It allows you to have like all the Qt libraries at the same place, and you can start debugging right away your Qt application. And so here the video is showing you how to connect the display to the board itself, and then like how it boots and how the OS is coming up on this LVDS display once again. So just as an FYI, I can see some question on the side about the videos. They are all available on our YouTube channel already. And a final extension that we're going to cover is the mini PCIe connectors. So it's not really like boundary devices specific here, and that's actually the good thing about it, is that the mini PCIe connector is standard. So you can buy off-the-shelf solutions like the one we see on the picture here, which allows you to connect an SSD hard drive to the board. And another example is to connect the modem that Pejman was talking about earlier, the EC25. And so, as a conclusion, we hope you've enjoyed watching the different capabilities of the Nitrogen8M Mini. Every daughter board and display are available and ready for you to evaluate the platform. Really, it's here to give you flexibility to make sure that you know what the platform is capable of, and to make sure that it fits the needs of your project. And once again, all our board support packages support the different options we've shown before, which is truly unique, and it will enable you, no matter the OS you pick, all those features are all supported properly. And as you saw, like, we will leverage many options from previous design, and we keep on listening to customers' feedback. So it is very valuable to us. Feel free to contact us if you have any question, or if you see a need for another daughter board that would bring a feature that's missing right now. So that is it for me. It is now your turn to ask any question you have on your mind. Thank you.
And thank you, presenters. We've been answering questions throughout the presentation, but we're going to pause now and see if we have any new submissions.
Hey, Gary, there was a question that I think you could jump into about what is our kind of regression testing or validation that we do on every new BSP. Maybe you could talk a little bit about that process.
Yes, so actually what we do is that we run the same, we have our own application at the end of the manufacturing line that checks every component. So that will check that the GPU is working properly, the VPU is working properly. And so we run this as soon as we have a new kernel, we run it on that new kernel. As soon as we have a new Yocto image, we run it on it, and so on. So this is our own unit test framework, if I would say, but that is what we run. And if you're interested in having that framework, we can share it with you. One question I've seen is about the slides. Yes, they will be available after the presentation. I think they will be sent automatically. Peter, correct me if I'm wrong.
That is correct. We will post the recording, and you'll see at the end of the presentation my contact information, and we'll also share slides with all those through the GoToWebinar as well. Any further questions? And if we miss any, we can follow up with you individually as well.
Hey, Gary, what about CEC and HDCP support on the MIPI DSI?
So there is no HDCP support, and CEC is supported. Like, so we read the CEC from the display to be able to properly set up the resolution.
So there's the question about how common is it for customers to use an SVC as is, but develop their own carrier daughter board. It's very common. So really depends on the amount of changes needed. So if you need something simple like a CAN bus or an RS-45 or something pretty simple, customers can take the mini SVC and really design a quick and simple daughter board to provide those signals. If it starts to become more complex, then it makes sense to use the SOM and design a custom carrier board, because the size area for the daughter board on that single board computer is limited. So if you start adding a lot of different things on there, it becomes unwieldy. It becomes difficult to control. So in that case, we would recommend people to use the SOM and design their own carrier board. And really throughout both options, we're happy to share what reference designs that we've already done, again, to help kind of move that process along further. Gary, there's another question about multiple camera inputs. So we do have boards that do support multiple cameras, and maybe Gary, you can talk about the other family, but how that's done.
Yeah. So there are different questions in that question. If we're talking different CSI ports, there is only one on the I.MX LM Mini, so you can only connect one MIPI CSI daughter board to it. If you're interested into having two MIPI CSIs, we have the I.MX MQ that offers that, or the upcoming I.MX M Plus that also will have two MIPI CSI inputs. If you're talking about virtual channels that allows to some kind of like having like different MIPI CSI over the same lines, that is not supported on the I.MX LM Mini.
Great. There's a couple of other questions. So there's a question about, does our SOM comply with any kind of specific standards? So we don't. So the SOM is a proprietary boundary devices pinout. It uses SODIMM form factor. And the kind of the reason we did that, in the ARM space, it's not like the x86 space where really pin muxing and things like that can change between a Q7 and even various manufacturers of Q7. So it's not necessarily software compatible, and even in some cases not even hardware compatible. So the concept of having a modular standards-based approach is not the same as it is on an x86. I will say that we do provide guarantees on our SOM designs. So for all of our customers that use our SODIMM SOMs, it's proprietary. So we sign agreements that say, if something happens to boundary devices, or if we no longer manufacture the board, that we will release our design files to customers, so they are not stuck with a board that they can't get anymore. So we have all kinds of agreements in place to give that peace of mind that the board will be around and the customer's not, going to be stuck, without a processor platform.
There is a question about Yocto saying that some customers find Yocto complicated. Can you elaborate what is the issue with Yocto? It's not an issue. It's just like some people prefer different interfaces to like customize their build system. And build route is very simple, as it is using like a menu where you can select which package you want in your image. So it's very easy for the newcomers, whereas Yocto may require some more knowledge. That's it. So it's not an issue. It's just some preferences from one customer to another.
Okay, if there's more questions, I guess we can reach out to the attendees individually. In the meantime, I want to thank our presenters, thank our webinar attendees and customers, and let you know we'll be posting the recording on our website and YouTube channel. And again, thank you. Be safe and goodbye until next time.